We are going to go over a question. Circular motion. A belt runs on a wheel of radius 44 centimeters. We can have a diagrammatic representation of that. This is a wheel, and we've been told the radius is 44 centimeters. Okay, like that. During the time the wheel takes to coast uniformly to rest from an initial speed of 1.6 revolutions per second to 9.5 meters of belt length pauses over the wheel. Find the deceleration of the wheel and the number of revolutions it turns while stopping. Okay, so really what are they trying to ask us about? We want to determine the acceleration on the wheel. Now look at the velocity that we've been given. We've been given the speed in revolutions per second first, that is the speed of the wheel. And we've been told the wheel has got this radius. We know that angular acceleration is equal to final angular speed minus initial angular speed divided by the change in time. But do we even have the time here? Not really, we don't have the time. But let's just gather the information that we have. The radius is 44 centimeters, which we can convert to meters. In 1 meter there is 100 centimeters, and this is going to be 0.44 meters. During the time it takes to coast from an initial speed, so initial speed that is given as 1.6 revolutions per second. We can as well convert this to radians per second. We know that in 1 revolution there is 2 pi radians, and so this is going to be 1.6 multiplied by 2 pi. This is about 10.05. This is radians per second, because the revolution cancels. Another thing that we've been told, 29.5 meters of the belt, because the belt is wrapped around this, it's wrapped around the circumference of this wheel. That means the circumference of the wheel is equal to the length of the same belt, but the distance or the length of which the the wheel is going to pass over the belt, that is the distance, is 29. So S 29.5. We can as well convert this, it is in meters, we can convert it in terms of the angle theta, and you know that the angle theta is simply radius times, okay, not radius, but we know that anything linear is simply radius by the angular term. So to find this theta, we're just going to divide the distance here by the radius. That is how we get to go about it. So we're just going to multiply this by 1 divided by the radius. The radius is 0.44, and this would now be in terms of theta. It will no longer be distance, linear distance, but angular distance when we divide by the radius. So 29.5 divided by 0.44, and that is going to be 67.045. This is in radians. Okay, now that we have got this information, I want to find the deceleration of the wheel. How do we get to find the deceleration? We know the equations of motion. We know that final velocity squared is equal to initial velocity squared plus 2as. We can as well write this in terms of angular. Final velocity, that would be the angular final squared, is equal to the angular initial squared plus 2, and then it becomes angular acceleration, and then s becomes a theta. Now we want this to go to a stop. So the final velocity, that is going to be 0. Even the angular is going to be 0. The initial velocity, we know that is 10.05, and that is squared plus 2, we don't know the angular acceleration, but we know the angular displacement, that is 67.045, and this is 0 is equal to 10.05 squared, that is 101.025, actually is 0025, and then plus, we're going to multiply the 67.045 by 2, that is 134.09, and then there is alpha there. I'm going to take this term the other side, so it becomes negative 101.0025 is equal to 134.09 alpha. What remain with alpha, we'll just divide the negative 101.0025 by what we have there, and that is negative 0.75. This one I converted them to radians per second, so this is radians per second squared. I can as well take the answer in revolutions per second squared, and this will be angular acceleration is equal to negative 0.75 radians per second squared multiplied by, in one revolution, so we're going to put a revolution on top. In one revolution we have got 2 pi radians, so that this radians and the radians cancels out, and the answer is going to be in revolutions. So just divide the 0.75 by 2 pi, and that will give us negative 0.12. This is in revolutions per second squared. Alright, that is going to be it. Now the other part of this question is find the deceleration of the wheel and the number of revolutions it turns while stopping. We already determined the number of revolutions it turns while stopping. This very distance, that is the number of revolutions that is going to turn while stopping. But this distance we found in what? Okay, the distance here we have got, we said theta is equal to linear distance divided by the radius, and this gave us the linear distance. We said that is 29.5, said the radius was 0.44, and this will be 29.5 divided by 0.44, which gave us 67.045 radians. But we want the number of revolutions, so 67.045 radians we're going to multiply by, in one revolution we have got 2 pi radians, so that this one and this one gets to cancel. So just divide this 67 by 2 pi, and that is going to give us 10.67 revolutions. Well, thank you so much for watching. Please get to subscribe and enjoy your day.